Welcome to section 5.5. We are doing long division today, and before we even try to start with polynomials, I want to make sure that we understand the long division of regular numbers, of real numbers. And this is something that you did in 4th or 5th grade, but from what I've heard from students that some of the teachers taught it in different ways. So I'm going to walk you back through traditional long division, and I'm going to take you in the same format that we will do with the polynomials for questions 3 and 4. Okay? So here's what we want to do. Take a look at number 1. We want to take 112 and we want to divide it by 4. Okay? So what I'm going to do is we're going to go number by number. And I'm going to say, does 4 go into 1? The answer is no. Okay? So then I'm going to group the first two. Does 4 go into 11? Yes, it goes in twice. So I'm going to put a 2 on top. I'm going to put a 2 on top, and 4 times 2 is 8, so I'm going to drop the 8 below. Now the question is, if it goes in twice, how many is left? So 11 minus 8 then is 3. And then I'm going to drop the 2 down, okay, and I'm going to ask myself one more time, does 4 go into 32? The answer is yes, 8 times, because 8 times 4 is 32. When I subtract, I get 0. So my answer for this question is 28, and we've done this without a calculator. Okay, so let's try one more. I'm going to ask to take 5,546, and we want to divide it by 12. This one's a little bit tougher because I'm dealing now with a double digit. But take a look. Can 12 go into 5? The answer is no. So can 12 go into 55? Yes. And it's going to go in 4 times because 4 times 12 is 48. And I'm going to subtract. I apologize. 55 minus 48 is 7. And once I figure out what's left, I'm going to drop one number at a time. Okay? Now, does 12 go into 74? The answer is yes, 6 times. Because 6 times 12 is 72, so I subtract 72. 74 minus 72 is 2, and then I'm going to drop the last number, 26. And we go one last time. Does 12 go into 26? The answer is yes, twice. Because 2 times 12 is 24. When I subtract, I get 2. Now, in elementary school, they let you say remainder of 2, right? I had 462 with a remainder of 2. In Algebra 2, we're done with that. What we have left is 2 divided by the 12 that we started with. So I have 462 and 2 twelfths, but 2 twelfths can be reduced, so I have 462 and 1/6. This is our answer. Okay, so there's no longer available to have the R. You actually have to take your remainder and then divide it by whatever number you're dividing by the 12. Okay, now we're going to take the same process with polynomials, and we're going to walk this through again. And I'm going to take you the same way. So I'm taking x cubed minus 5x squared minus 7x plus 2. And I'm going to divide that by an x minus 2. Okay? Now what I'm going to do is start with the x outside. I'm going to only deal with that for a minute. And I'm going to say x times what will give me the x cubed? Well, I have 3 x's here. I only have 1 here. So an x squared would get me x cubed. So I take this x squared and I'm going to multiply it by both of these numbers out here. So x squared times x is an x cubed, and I'm going to put it right underneath. X squared times negative 2 is a negative 2x squared. And like we did above, once we find our answer, we're going to subtract it like we did above. So I'm going to put the subtraction in, but I'm going to put parentheses because we have to subtract the whole thing. Now, x cubed minus x cubed, those are gone. Here's where the tough part comes in. Negative 5 minus negative 2. That really means plus 2. So negative 5 plus 2 is negative 3 with an x squared. Once I find what I have left, I drop the next thing down, so minus 7x. And I'm going to do it again, only I'm going to change my color here a minute so you can see the next step. I'm asking x times what is negative 3x squared? Well, I'm missing a negative 3, and I only have one x, I need two x's, so I need one more x. And I'm now going to take this negative 3x and I'm going to multiply it by both of these. So negative 3x times x is negative 3x squared. Negative 3x times negative 2 is a positive 6x. And once I find that, I'm going to subtract the whole thing, so I'm going to put parentheses. All right, negative 3x, and then subtract a negative means plus 3x, cancel it out. Negative 7 minus 6 is negative 13 with an x, and then I'm going to drop down the positive 2. Okay, let me switch my color one more time. All right, x times what is negative 13x? Well, we're missing the negative 13. So I take this negative 13 times both. So negative 13 times x is negative 13x. Negative 13 times negative 2 is a positive 26. And I'm going to subtract it. Negative 13, subtract a negative means plus 13, that's gone. 2 minus 26 is negative 24. And when we go to write our answer, we're not going to say remainder of negative 24. We're going to use the negative 24 in the polynomial that we divided by. So plus negative 24 over the x minus 2 that we were dividing by. And this then is our final answer. X squared minus 3x minus 13 plus negative 24 over x minus 2. Okay, and we're going to walk through one more. On your quiz and your test, you will be required to do some of them with long division, so please be aware of that. So let's go one more. I have an x plus 3 that's going into 2x cubed plus an x squared minus an 8x plus a 5. Okay? All right, we always start with the x's. We care about the x's here for a minute. X times what is 2x cubed? Well, I'm missing the 2, and I'm also missing an x squared. So I take 2x squared times x to get 2x cubed. 2x squared times 3 is plus 6x squared. And then I subtract. 2x cubed minus 2x cubed is gone. I'm going to throw a 1 in here a second. 1 minus 6 is negative 5 with an x squared. And once I find my remainder, I drop down the negative 8x. Okay, let's change our color again so we can see the next step. X times what is negative 5x squared? Well, I'm missing the negative 5, and I also need one more x in order to get an x squared. So negative 5x times x is negative 5x squared. Negative 5x times 3 is negative 15x, and I'm going to subtract this. All right, negative 5 minus negative 5 goes away. Negative 8 minus a negative, so that means plus 15 is 7x, and then we drop the 5. The hardest part about the long division, truthfully, is the addition and subtraction mistakes that we could potentially make. Change our color one more time so that you can see the last step. X times what makes 7x? Well, it's a positive 7. So 7 times x is 7x. 7 times 3 is 21. I subtract the whole thing. The 7x's go away, and you will always make them go away by the number you picked. 5 minus 21 is negative 16. So my remainder should say plus negative 16 over whatever I divided by, the x plus 3, and here's my answer. Okay, it's called a quotient. So the long division is going to walk you step by step through this. We will do a warm-up like it in class, but this is the long division part. And our goal basically is to figure out, if I take an x plus 3, this linear factor out, what is left in my polynomial. Okay? Now we are going to show you a shortcut, because let's be honest, this does take a while. Please know though, you will have to do long division both on the quiz and on the test. So please be aware that long division is a requirement. You cannot just do the short version that I'm going to show you. Okay, so be aware. All right, here we go. Let's slide this down, and we're going to do what we call synthetic division, which is the short version. Okay, first and foremost, you have to have a zero of a linear polynomial. That means your linear, what you're dividing by, has to be like mx plus b. Okay, single x is what they're talking about. So what you divide by has to have a single x. And then all we're going to use is the coefficients. We're not going to mess with the actual variables that are in there. So here's what I'm going to do. I'm going to take this x plus 2, and I'm going to set it equal to 0 so I can find its 0. Oh, let's start by actually putting the right one in. It was x minus 2. Now, in order to solve it, we add 2 to both sides. Therefore, my 0 is a positive 2. Now, you can look at it and go, but Ms. Japanik, it's the opposite. That's fine. The harder we get, though, please be aware you might have to solve. What I'm going to do is take that 0, and I'm going to put it outside of a box. And I'm going to do kind of the upside down version of long division. In the top row, I'm going to put the coefficients of my polynomial. That means the number in front of the variable. So in front of the x cubed is a 1. In front of the x squared is a negative 5. In front of the x is a negative 7. In front of, just the single number is a 2. Okay? Now the process for synthetic division goes like this. We drop the first number underneath the bar. We take that number and multiply it by the 0, so times 2. 1 times 2 is 2, and we put it beneath the next number. Whatever numbers are inside the box, we are going to add them together. Okay, so negative 5 plus 2 is a negative 3. We do it again. Negative 3 times 2 is negative 6. And negative 7 plus a negative 6 is negative 13. Negative 13 times 2 is negative 26. 2 plus a negative 26 is negative 24. Okay, now, here's what this means. The number at the end is always your remainder. And then we go in order. The constant term, or the number term, the x term, and then the x squared term. What this says is if I were to divide these, my answer, my quotient would be x squared minus 3x minus 13 plus negative 24 over my original polynomial of x minus 2. Now, if you look at the question right directly above it, it is exactly the same question. And if you look at the coefficients that you're doing, you would have seen that negative 5x squared plus 2x squared got you negative 3x squared. And negative 7 plus a negative 6 got you the negative 13. And you should be able in your long division to look at it and go, oh, that's where the numbers are coming from. So I want to do the same thing with the other one. My 0 of my polynomial is a negative 3, since it's the opposite of what's there. So the negative 3 goes outside of my box, and the coefficients go inside. So I have a 2 for the x cubed, I have a 1 for the x squared, I have a negative 8 for the x, and I have a positive 5 for the constant. Okay, so we walk through this again. You drop the 2, 2 times negative 3 is negative 6. When I add that to 1, I get negative 5. Do it again. Negative 5 times negative 3 is a positive 15. Negative 8 plus 15 is a positive 7. One last time. 7 times negative 3 is negative 21. 5 plus negative 21 is negative 16. So the last number is our remainder, and then our constant, our x squared. So my polynomial that I end with, my quotient, 2x squared minus a 5x plus 7 plus negative 16, and you go back to that linear factor divided by x plus 3. And you'll notice we got the same answer as the one above, and you should be able to see again here, these are the x squareds that I subtracted. Here's the x's, here's the constants, and you should be able to find those in your long division to see that you're getting exactly the same thing. Okay? So we're going to use the synthetic division, and the point is this division will help us find some things in polynomials. So I want to walk through a couple of questions on the back with you. So let's flip the page. Okay, I'm going to start with number 6. Find the other zeros if x minus 2 is, or x equals negative 2 is a 0. So they're already giving you the 0. So what I want to do is synthetic divide this a minute, because they gave you a 0, and we're going to figure out what to do with our quotient when we're done. So I use my coefficients again. 3, negative 4, 28, negative 16. Now here's the biggest thing. If they tell you it's a 0, your remainder should be 0. Okay? If they tell you it's a 0, your remainder is a 0. So take a second, let's synthetic divide. We drop the 3. 3 times negative 2 is negative 6. We then add the numbers inside together. Negative 4 and negative 6 makes negative 10. Negative 10 times negative 2 is a 20. Oh, this is a negative 28. I better fix that first or this isn't going to work out. Negative 28 plus 20 is a negative 8. Negative 8 times negative 2 is a positive 16. So I end with a remainder of 0. I always make it a smiley face because that's what we need to have. What that says, this is my remainder. Here's my constant, my x, and my x squared. I now have this polynomial, 3x squared minus 10x minus 8, and my goal is to find the remaining zeros. So I set this equal to 0. Now you have a choice. You can quadratic formula, or you can try and factor. And I'm going to try and factor because, let's be honest, I think that's easier than quadratic formula. Because there's a leading coefficient, I need to use the snip method. So 3 times negative 8, because we do A and C, is negative 24. My goal for B is to add to a negative 10. Well, I could have 8 and 3, 6 and 4, 12 and 2, 24 and 1. These are kind of common ones. Now, one of these numbers has to be negative to get the negative 24. If I look at that, I'm going to pick negative 12 and a positive 2 because that adds to the negative 10. And we said you take each of these, negative 12 and you 2, and you divide them each by the leading coefficient of 3. This 2/3 can't be reduced, so I'm going to put an x. But this negative 12 over 3 reduces to negative 4 over 1, so I'll put an x there. My two factors then are x minus 4 and 3x plus 2. If I want to find the zeros of each of these, remember back to chapter 4, I'm going to set x minus 4 equal to 0 and I'm going to set 3x plus 2 equal to 0. To save us a little bit of time, we know that this is x equals 4, or x equals negative 2/3. Now you can actually solve that, but the idea is that we're going to relate some of what we're doing back to chapter 4 and finding zeros. Zeros are another word for x-intercepts. So they're trying to find x-intercepts on a graph. Now, the reason I know that I should have 3 answers is because my degree here, my leading or my highest exponent, my degree is 3, which means I should have 3 zeros, or 3 solutions, or 3 x-intercepts. We found one of them was negative 2, one of them is a positive 4, and one of them is a negative 2/3. And so when we talk about determining whether our answers are correct, we should really talk about how many solutions we got and how does that relate to the original polynomial. Okay, so I'm going to take this again, we're going to do another one, and then I'm going to let you do one on your own to get your notes points. So let's slide this down. Okay, find the other zeros if h of 3 is 0. What that means is that x is 3 is a 0. Okay, when you plug a 3 in, you get a 0 out. That means we want to use the number 3. So 3 goes outside of the box. My coefficients are 1, negative 2, negative 23, positive 60. According to my process for synthetic, drop the 1. 3 times 1 is 3. I then add the numbers inside together. Negative 2 plus 3 equals 1. 1 times 3 is 3. Negative 23 and 3 is negative 20. Negative 20 times 3 is negative 60, which when you add it to 60 is 0. That's a good thing because we don't want a remainder. So if this is my remainder, I have my constant, my x squared. So the polynomial I have is x squared plus x minus 20, and I want to find the other zeros, so I set it equal to 0. All right, I'm going to factor this because it's an x squared. X squared is x and x. Negative 20, I know I need 5 and 4 because that can get me a 1 in the middle. But the 4 needs to be negative. So I have an x plus 5 and an x minus 4 equals 0. And if we go back to chapter 4, this tells me that x is negative 5 or x is a positive 4. So here's 1 0, 2 zeros, 3 zeros, and I know I need 3 zeros because I have a degree of 3, which means I need 3 solutions. Okay, so same thing. We're going to give you number 1 at the bottom. That one I want you to do before coming in. I truthfully think it's going to be no big deal. Take a look at it. I know 175 is big, but again, what's nice about this is you don't have to do anything with exponents. You don't care about the x squareds or cubes or anything like that. You just can do addition and multiplication. Okay, so that's the end of video 5.5. Thanks for watching.